An LRU cache has a fixed capacity. When you get a key, you return its value or -1 if it is not there, and the key becomes most recently used. When you put a key and value, you update if it exists and mark it recent, or if the cache is full you evict the least recently used item and then add the new one. The goal is to implement both operations in constant average time. We need to find and update items by key in constant time, and we need to know which item was used least recently so we can evict it when the cache is full. Use a hash map for O1 lookup by key. Use a doubly linked list to maintain order, most recently used at one end, least recently at the other. When we use a key we move its node to the recent end. When we add a new key and the cache is full we remove the node at the old end and delete that key from the map. So the map gives us the node for a key, the list gives us recency order. Move to head on use, evict from tail when full. We have two data structures, a hash map and a doubly linked list. The order of nodes in the DLL determines recency, head is most recent, tail is least recent. Each node holds key, value, previous, and next. We use sentinel head and tail nodes. The hash map maps key to node, so we find the node in O1, and can then move it in the list. For get, if the key is not in the map return -1. Otherwise remove the node from its current position, add it to the head, and return its value. For put, if the key is in the map, update the value and move the node to the head, then return. If the cache is full, the least recently used is tail.previous, remove that node and delete its key from the map. Then create a new node, add it to the head, and put it in the map. Capacity 2. We start with an empty cache, head and tail sentinels, no entries. The map is empty. Put 1,1. We add a new node with key 1 and value 1 at the head. The map now maps key 1 to this node. Put 2,2. We add a new node at the head. Now key 2 is most recently used and key 1 is least recently used. The map has two entries. Get 1. We look up key 1 in the map and follow the pointer to the node. We return the value 1 and move this node to the head so it becomes most recently used. Put 3,3. The cache is full. We evict the least recently used entry, key 2. We remove its node from the list and remove key 2 from the map, then add the new node for key 3 at the head. Get 2. Key 2 is not in the map, we evicted it. We return -1. Get 3. We find key 3 in the map, follow to the node, and return the value 3. Both get and put are constant time, we look up in the map, move a node in the list, and at most evict one entry. Space is linear in capacity, the map and the list each hold at most capacity entries. The LRU cache class stores capacity, a map from key to node, size, and sentinel head and tail. Get looks up the key, moves the node to head, and returns the value. Put updates if the key exists, or evicts the LRU and adds a new node if full. Constructor, store capacity, empty map, size 0. Constructor, store capacity, empty map, size 0. Initialize Sentinel head and tail and link them. Get method. If key not in map, return -1. Get the node from the map, remove it from its current position, add to head, then return its value. Remove node and add to head, return value. Return the value. Put method. If key already in map, update value, move node to head, return. Update node, remove from list, add to head, return. If at capacity, get LRU as tail.previous, remove it from list and from map, decrement size. Evict LRU, remove node, delete from map, size -1. Create new node, add to head, put in map, increment size. Remove node unlinks it from the list by connecting its previous and next. Add to head inserts the node right after the head sentinel. Previous nodes next skips to nodes next. Next nodes previous skips to nodes previous. Add to head, insert after head. Set nodes next and previous, node goes between head and old first. Wire head and old first to node.